Space, the final frontier. It beckons us, challenges us. Mars, our rusty red neighbor, whispers promises of new beginnings. But Mars is harsh, unforgiving. Its thin atmosphere, frigid temperatures, and lack of a global magnetic field make it hostile to life as we know it. So we dream of terraforming, of transforming Mars into a second Earth. A daring idea takes hold. What if we nuked Mars? Could we shock a dead planet back to life? Could such an act of cosmic violence be the key to unlocking a Martian genesis? The question hangs heavy in the air, a testament to our audacity, our desperation, and our boundless capacity for both creation and destruction. It's a question that forces us to confront not just the limits of our technology, but the very essence of our relationship with the cosmos. The answer, as with all things in the universe, is far from simple. Mars is cold, its surface locked in a perpetual deep freeze. Beneath this frozen crust lies a potential reservoir of life-giving water ice. Proponents of the nuclear option argue that detonating nuclear devices could release this trapped water vapor. The theory is this: the intense heat would melt the ice. This vapor would rise, thickening the atmosphere. A thicker atmosphere could trap more heat, leading to a runaway greenhouse effect. Temperatures would rise, further melting the ice and potentially creating bodies of liquid water on the surface. Imagine rivers carving through the Martian landscape, lakes reflecting the alien sky. It's a tantalizing vision, a testament to the seductive power of this radical idea. But like all grand visions, the devil is in the details. Could we truly engineer such a transformation, and at what cost? The answers lie in understanding the formidable challenges and the potential consequences of unleashing such power on a planetary scale. The power of a nuclear weapon is both awe-inspiring and terrifying. It's the embodiment of Einstein's famous equation, ELMC2, where a tiny amount of mass can be converted into a staggering amount of energy. In the context of Mars, this energy could be used to melt ice, vaporize rock, and create massive shock waves. The scale of the detonation would depend on the yield of the weapon and the altitude at which it's detonated. A surface detonation would release most of its energy as heat and radiation, vaporizing the surrounding area and creating a massive crater. An airburst, on the other hand, would spread the energy over a wider area, potentially melting more ice and releasing more water vapor. The choice of weapon yield and detonation altitude would be crucial. Too small, and the impact would be negligible. Too large, and we risk fracturing the planet or blasting away the very atmosphere we're trying to create. We have a glimpse of the destructive potential of impacts here on Earth. The Chicxulub crater in the Yucatan Peninsula, Mexico, is a stark reminder of the cataclysmic events that can reshape planets. This 180-kilometer-wide scar is believed to be the impact site of an asteroid that wiped out the dinosaurs 66 million years ago. The impact released an estimated 100 million megatons of energy, triggering earthquakes, tsunamis, and wildfires on a global scale. Imagine that kind of devastation on Mars. The dust and debris ejected into the atmosphere would block out the sun, plunging the planet into a long, dark, and frigid winter. The impact could also trigger volcanic eruptions, further polluting the atmosphere and making it even more hostile to life. The lesson of Chicxulub is clear. Even with the best intentions, our attempts to manipulate the cosmos can have unintended and potentially catastrophic consequences. Let's assume for a moment that we can control the nuclear explosions, avoiding a planet-sterilizing cataclysm. Could we actually generate a breathable atmosphere on Mars? The initial blast would release a massive amount of water vapor, carbon dioxide, and other gases. This could thicken the atmosphere, but it wouldn't be breathable for humans. In fact, it would be highly toxic, consisting mainly of carbon dioxide with a smattering of other noxious gases. To make Mars habitable for humans, we would need to further terraform the atmosphere. This would involve converting carbon dioxide to oxygen, perhaps through the introduction of genetically engineered algae or bacteria that thrive in Martian conditions. But this process would take time, perhaps centuries or even millennia. And there's always the risk of unforeseen consequences. Would the newly released gases be stripped away by the solar wind? Would the planet's weak gravity be able to hold onto a thicker atmosphere? The ethical implications of nuking Mars are as vast and complex as the scientific challenges. One of the most pressing questions is this: what would happen to any existing life on Mars? While we haven't found definitive proof of life on Mars, there's a chance that microbial life exists beneath the surface, perhaps in the very ice we're proposing to melt. Detonating nuclear weapons on Mars could wipe out these life forms before we even have a chance to discover them. Even if life doesn't currently exist on Mars, the planet could still be considered a pristine environment, a scientific laboratory where we can study the early evolution of the solar system. Nuking Mars would contaminate this laboratory, making it impossible to unravel the secrets of its past. The question then becomes, do we have the right to impose our will on another planet, potentially destroying any life that might exist there, even if it's microbial? The debate over nuking Mars mirrors our own struggles with nuclear weapons here on Earth. The destructive power of these weapons is undeniable, and their use represents a profound ethical dilemma. The detonation of atomic bombs over Hiroshima and Nagasaki in 1945 cast a long shadow over humanity. The devastation and suffering caused by these events serve as a stark reminder of the human cost of nuclear warfare. Even the testing of nuclear weapons has left an indelible mark on our planet, contaminating areas with radioactive fallout and raising concerns about the long-term health effects of radiation exposure. The lessons learned from our own history should guide our actions as we venture further into space. We must proceed with caution, recognizing that the decisions we make today will have far-reaching consequences for the future of humanity and the cosmos. The idea of nuking Mars is a testament to human ingenuity and perhaps our desperation to find another home in the cosmos. It's a concept that sparks the imagination, but also raises profound ethical and scientific questions. The potential benefits, such as releasing trapped water and thickening the atmosphere, are enticing. But the risks, including triggering a catastrophic impact event and contaminating the planet with radiation, are equally significant. Ultimately, the decision of whether or not to nuke Mars is a question for future generations to answer. But the debate itself forces us to grapple with fundamental questions about our place in the universe and our responsibility to protect the fragile ecosystems, both on Earth and beyond. As we stand on the precipice of this new era of space exploration, we must proceed with wisdom, humility, and a deep respect for the delicate balance of the cosmos. The future of Mars and perhaps our own may depend on it.
Don't forget to like, subscribe, and share this video. That's all for Nifty Narration.